Hello, welcome to Global Azure Bootcamp Online. We're going to be speaking about migrating to SQL Managed Instance. For those of you who don't know me, my name is Bob Duffy. I work as a database architect out of the ProData SQL Centre of Excellence in Dublin. I'm a certified architect on the SQL Server platform, or a SQL Ranger, a certified master, and an MVP. I spend most of my time helping enterprise customers architect, design, and implement solutions on SQL Server, and nowadays mostly in Azure. So this talk is really about our experiences with chatting and working with customers at Microsoft on SQL Managed Instance. So what we're going to cover in this session is a brief intro about kind of SQL Server Managed Instance. Why do we need it? Its architecture, kind of how it works. How much is it going to cost you? What sort of capacity and performance is it going to give you? Most of the talk is going to be focused on the migration process and tools. How do I migrate to this new environment? And we're going to be spending a little bit of talk about the other components other than SQL databases, in integration services, analysis services, and reporting services. But for the whole, most of the talk is going to be focused on the database aspects. So why do we need SQL Managed Instance? Well, there's already a lot of database offerings, right? And if you're building a new database, you can use some of the other platforms as a service, Cosmos, Databricks, SQL DW. But if you've got a relational database running on SQL Server, you're kind of slightly limited on options. Infrastructure as a service, if you're not going platform as a service, but if you want to go platform as a service, the previous offering was SQL DB, or a single database. So managed instance effectively gives you a friction-free way of migrating to the similar architecture to single database, but in a fully managed service for an entire instance with much better compatibility. Now, there's 4 tenets of that, right? One, it's a fully managed service. So what that means is you get your 99.9% SLA, you get your full stack updates, patching, and backups, and you also get compliance with all major industry standards for threat detection, automatic alerting. Features like intelligent query processing and intelligent insights, where it take the logs and apply sort of AI engines to help you identify things like lock-in, blocking, and performance. So not quite self-tuning, but it's heading in that direction. Compatibility, almost 100% compatibility. So all of the previous features that SQL DB had problems with, SQL CLR, the job system, cross-database joins, these are all going to be fully supported in managed instance. Security-wise, it gives you full isolation. So this now means there's no public endpoints. So as soon as you connect it, it's connectable to your internal LAN without having to go through the houses to avoid public endpoints. And the last thing is obviously licensing. Because you're licensing the instance, it can be a lot more attractive when you've got a large number of user databases to license, and Microsoft is going to give you a lot of incentives. You can get the reserved instances for up to 33, and Azure Hybrid Benefit will let you transfer your on-premise licenses over to this kind of new offering. So when you combine the two, you can get about up to an 80% discount on the license. So it can be pretty attractive. So how does SQL Managed Instance work, and how does it differ from a normal installation of SQL Server on premise? Well, the first thing to bear in mind is there's 2 very distinct offerings. One is the general purpose offering, which is the mainstay of SQL Managed Instance. For that one, there's a bunch of active compute nodes that have basically SQL Server installed on them, but the data is located remotely on a blob store. So when you create a database, you're effectively provisioning a remote SSD on the blob store on one of the standard SSD offerings, P10, P20, P30 for a terabyte. So your performance of your throughput is dictated by the performance of the remote blob store, and your latency is slightly increased because obviously the compute has to cross to get to the storage. From Microsoft's website, it's designed for typical performance, so not super duper high throughput and low latency requirements. Now, the second offering is completely different architecture where the compute and the storage is co-located. So what you get is basically a node that has a super fast SSD. So some of the NVMe SSD, I think we've benchmarked it about a gigabyte per second or so. And what you get is up to 4 endpoints, so 2 by default, and you can get 4 if you want, with an always-on availability group synchronously replicating the data between them. So all of the nodes have the same data, and the secondary, or some of the secondary endpoints, can be set to be read-only, so you can scale out reads as well, and you've effectively got geographic failover. So this business critical tier, as it's called, is obviously aimed at applications that want the very best in terms of latency and availability. Now, let's have a brief look at the costings and how it works out. If we could compare managed instance to running on a VM, you'll see that the general purpose offering here, I've got the 8-core, it comes in at about 1,242, is a little bit more expensive than standard edition when kind of run on a similar spec VM, like an 8-core with 56 gig of RAM. But what you're getting for the tiny extra cost is no OpEx in terms of managing Windows or anything like that, and all the features of Enterprise Edition. So it's on par with Enterprise Edition, but you're effectively getting that for almost the cost of Standard Edition. And don't forget all the license savings that I mentioned. Reserved instance and Azure hybrid benefit. They all apply to both the compute and the licensing aspects. Business critical works out slightly more expensive than Enterprise Edition, but don't forget that what you're getting for that is a minimum of 2 nodes. If you were to try and deploy an availability group yourself in Azure, you'd have to pay for 2 nodes, and it'd be super complex because you'd be deploying load balancers, instances in different regions and so forth. Okay, so the costs are quite attractive. They're also super attractive if you compare them to SQL DB, because the cost of general purpose is exactly the same cost as if you provisioned an 8-core SQL DB by itself. But what you get is a whole instances with up to 100 user databases. Okay, so cost, we can say, quite attractive. Now, performance and capacity is something you have to be very careful of, right? Because you have to make sure that it's going to perform as well or better, I guess, than what you're migrating from. So there's an excellent link here at the bottom of the page where you can read the resource limits. Now, obviously, most of the limits scale up in terms of the size of cores. So, 8, 16, 24, all the way up to 80. RAM scales up on that basis, starting at about 56 gig of RAM if you're on a Gen 4 8-core. Now, what we're mostly interested in is the data throughput, right? Because SQL servers are all about transferring data, right? Your data file throughput depends on the offering. On general purpose, it's largely dictated by the type of SSD that your data files are on, right? If it's only a tiny file, like a couple of gigabytes, it's going to be on a tiny SSD, which is probably not going to do more than 100 IOPS or so. But if it's up to a terabyte in size, you might get 200 megabytes per second, right? So throughput is largely dictated by that. Ultimately, one thing that is a bit of a blocker is the log throughput. Because it's synchronously replicated, the general purpose will only give you 22 megabytes per second of log throughput, and the business critical, even with the 80 core, will only give you about 50 megabytes per second. So you've really got to check that that sort of capacity is okay for the workloads that you're moving. So how do I migrate to this new managed instance? Well, the short answer is it's very straightforward. Managed Instance is fully natively compatible with the SQL Server backup. So on your, what we're calling the on-premise, but it could be SQL inside a VM in Azure, you just got to get your backup into Blob Store in Azure, and from there there's a native restore direct from the Blob Store to the SQL Managed Instance. Now, if you're running 2012 and above, there is a native backup direct to the Blob Store. If you're running below 2012, or if you've got a slow internet connection, what you can do is just take a local backup, and then there's tools like AZ copy and stuff to copy the backup to the Blob Store. So you can always get the backup into a Blob Store from kind of some way. Now, that's kind of the short answer, right? The long answer is, there's more to migrating SQL Server than just copying the sort of databases over, right? So a typical project might go through these 3 steps, right? Planning, the migration itself, and then some sort of post-migration tasks. So we're not going to talk about post-migration, right? That's kind of a whole topic in itself. But let's talk about planning and the migration. Well, you're going to need to have an inventory of your SQL servers and then do some sort of capacity planning to understand what size of SQL server you want, what sort of throughput and IOPS you need, and how much RAM you need, so you can match it to the correct SKU and target platform and stuff like that. You're going to have to do some sort of compatibility assessment to see if it really is 100% compatible, or if there's some sort of changes that you might have to make. Then you're going to actually do the migration by deploying the platform, configuring the network, so you're going to have to join its VNet to your VNets or create VPN or whatever you're going to do, and then you can do the migration of both the databases and what I'm calling the artifacts, like jobs, logins, bits that hang outside of the user database. So what I'm going to do is run through some of the tools and show a demo of them, right? So the first tool is a Microsoft Assessment and Planning Toolkit to help with the SQL inventory and the capacity planning. The next toolkit I'm going to show is the Data Migration Assistant, which is there for the compatibility assessment. Then the actual data migration services for after you've deployed the sort of target platform to migrate the sort of database over. Now that's only one option, and that genuinely only transfers the databases. To transfer jobs, logins, and stuff like that, you could script them out manually, but there's a lovely tool set called DBA Tools, which is an open source PowerShell library to do that. So the first tool that we're going to quickly look at is the Microsoft Assessment and Planning Toolkit. So using this, we can create an inventory of the SQL servers and the databases and get their sizes, amount of RAM allocated, and we can also capture performance metrics over a period of time. So we can now get what the IOPS and throughput are, how much RAM is actually used, and the percentage of CPU used. And this is going to help us fit it into the right size of the managed instance. So I'm not going to show you a full demo, but what I have done is I've got some sample output from a previous run, right? So if we look at the server assessment spreadsheet that it outputs, you'll see I can run this against a bunch of SQL servers, which is very handy if I'm doing a consolidation where I'm moving multiple on-premise into one kind of managed instance. I can see all the version numbers, what service packs they have, but more importantly, I can get the capacity information, like how many processors did they have, how many cores, how old and slow kind of was the core, and how much RAM was allocated. On a per database level, if I go into the database details spreadsheet, I can now get for all of the user databases that were on all the servers, how big the kind of database was, how big the log files were, and the percentage of use. So I can now get capacity information on how much, how large disk space I'm going to need. And the third one is going to be the perf metrics result is going to be the performance counters that's captured over a period of time. So from here, I can get from here, for each server, I can now get the average utilization of the CPU, and this thing called a 95% quartile is going to give me a reasonably good estimate for what sort of for how many cores it's going to need, right? So if this instance needs 1.24 core and this instance needs that number of cores, I can eventually see how many instances I can squeeze into an 8 core, as well as the RAM, right? So I can see how much RAM is being kind of used there. And disk IOPS, I can get the IOPS as well. Now for SQL Server, you can convert IOPS into throughput if you know the IO size. So standard edition is going to be about 64K, and enterprise edition is going to be about a 64K IO size as well, unless you're running a large sort of data warehouse or something like that. So super useful metrics, and we can use those to hopefully pick the correct size of managed instance now. Now, the next tool I'm going to show you is the Data Migration Assistant. So again, there's a link here in the download, and I'm going to show you a demo of how you can use this to check for compatibility issues. So if I flip over to a VM that's got a SQL Server and this tool installed, here we go. I've installed it. Here's the link. So I run the kind of Data Migration Assistant, and I can ask it to do an assessment of migration. So I'm going to go Bob, database sources SQL Server, and in target type I can select SQL database managed instance. Okay, and to check for the database compatibility, I'm going to do that. I'm going to give it the name of SQL servers to connect to. I'm just going to connect to the one, and I'm going to do an analysis of all of them. I'm going to start the assessment, and it's whirring away there now. And I can do a check for compatibility issues. So it's going to go through all of the T-SQL in the stored procedures, all the tables, all the indexes, and look for deprecated features, both because of the fact that it's running on a managed instance, so it's running on Azure. There are some things that aren't going to work, like, you know, reserved functions that SQL CMD that's, you know, shelling outside SSIS DB type code, because obviously SSIS isn't supported, and so forth, you know. So it's just going to do a check through that, and it's going to come back and tell me if it finds anything. Now, I've run this good few times on some projects, and it's actually quite rare for us to find too much that's not compatible with. So let's just get this running. There you go. So in this case, it's saying there's absolutely nothing that's incompatible, but it's still worth actually doing that actually check. Now that we've done the map tool to get our inventory, found out how many databases we have, how much RAM and disk space we need, and what sort of throughput we need, and we've done the compatibility assessment, we can create the managed instance and start to migrate to it. Okay, so there's a few ways of creating the kind of managed instance. The most basic is via the Azure sort of portal, so sort of point and click and there's wizards, but there is the JSON templates, CLI or PowerShell via the RM kind of modules. CLI probably being the kind of newer and funky way of doing it. So let's see a demo of some of those, right? So if I just log into the portal in a web browser here, okay, so I'm in the portal in a web browser, I can connect to SQL Managed Instances there, and then I can select add, and I get this wizard come up here with various blades asking me questions, right? So I fill in my subscription, the instance names, a logon name, some standard SQL instance question like collation, where I want to store it, and so forth. And the important thing here is the pricing tier. So when I select the pricing tier, depending on what the output of the capacity planning was, I can select the number of cores, anything from 8 to 80 cores, and the max amount of storage. Now, bearing in mind, if I'm on general purpose, storage and performance is a per database thing, depending on the size of the SSD that's created. If I'm on business critical, obviously there's a shared pool of this kind of super fast local SSD that all of the kind of databases share. And if I'm bringing my own licenses, obviously I can save a rate load of cash. So for a business critical 8 core, I'm paying 3,400, but I'll get nearly a 50% saving if I'm bringing a license with me. Okay. When I click apply, it will create that. The other way of doing it, if I flip over to some PowerShell, is here's an example of some PowerShell script to actually do that. So and there's lots of templates available. If you Google online, you can find this kind of quite easily. There's a lot of parameters like what do you want to call your virtual network and the subnet. But you can see here, this is where I'm picking the number of cores, if I'm bringing my own license and so forth, what the resource group is, the network configuration, and so forth. And at the very end, there's this one function creates the new Azure instance based on all of the parameters above there. Now, it does take a minimum of about 3 hours to create an instance because there's a rake load of work to be done. It's got to allocate nodes, get SQL Server set up on them, get the failover working, and so forth, right? And if you're doing premium, it's got to create an entire availability group across 2 to 4 nodes, right? So there's a fair whack of work, and the first time that you create an environment, it can take up to 3 hours. Once you've got your virtual network and your subnets, adding additional managed instances into that is fairly quick. Okay. So that's how to do that. Now, one thing to bear in mind though is the managed instance is not connected to the public internet. So after you create it, and just leave that, you'll get a list of your kind of managed instances here. And the first thing you're probably going to want to do is to go to the quick start menu to grab hold of this script or a similar one to create a jump box. So a jump box is going to be a SQL Server in the same, in the same virtual network, okay, it's in a management subnet that you can RDP in and has got SQL Server Management Studio in, so you can connect to it. So I could literally copy this code, click on the Cloud Shell, and if I wanted to, I could paste this kind of code in, and in a couple of minutes, it would create me a VM. You can also go to the quick start if you want to create a VPN, or to start the kind of data migration services to migrate user databases over to it. So I've run exactly this script, and I have created a jump box. So here's my jump box. Just to show you this, if I go to the command prompt, I can see the computer name is jump box by default. Nice. And I can see I'm in this IP range that was created, and I can go to Management Studio. Now, I do actually have a SQL Server installed here because I'm using this as my source as well, but my source would usually be a completely different SQL Server. I can now connect to the connection string that came up when I created my managed instance. So it's called Bob MI. I've got a password, and here we go. I've now got a connection to my managed instance. I can create databases in exactly the same way. So if I go create kind of database Bob D, it'll create a disk that'll attach all the files to that is dedicated to just that user database. If I go to files here, I can see, look, there's my data file. Now, as you can see, the kind of disks are created as on blob stores. It's not like on the C drive or anything like that, you know. Okay, so that's the slight difference, but the experience for those of you used to using sort of Management Studio, you wouldn't really know that you were using a fully managed service in the cloud. You're going to see all of your databases, all your familiar environments. Here's my SQL agent here. If I go to management, I've still got things like the SQL Server logs. You know, I can double click there and get hold of the log file and so forth. So anything that I could do with the existing SQL Server in terms of management, I can continue to do on the managed instance. Now that we've deployed the managed instance, let's actually look at how we migrate the databases and other artifacts over to the instance. So the first thing I'm going to show you is data migration services. So this is a cloud-based service kind of running in Azure. There's a link at the bottom of the deck here to how to activate it and read the KBs. I'm going to go straight into a demo of that, right? So what I have is I have the Azure portal here. I can click on Azure Database Migration Services here. It's here. And I can click on Add. And when I do this, Blade comes out. I give it a service name, a subscription, a location, what virtual network I want it to be able to find kind of SQL servers on. So, and the tier, right? If I'm doing an offline, so I'm just getting backups that have previously been sort of taken, I can run it on a 1 core. Otherwise, I need the premium, which is 4 cores. Good news is, according to the blurb here, for the first 6 months of usage, the 4 core kind of migration server is basically free, right? I guess Microsoft is willing to give you a bunch of compute to help you migrate your data into Azure. Now, once you've created the service, you can then create a project, right? So over here, I've started the wizard to create the project. So I select the source. So this could be the IP of the SQL server, and you can create kind of multiple projects, one per source SQL server. Then I select the target. So the target is going to be the managed instance. There you go. So I give it the name, how I'm going to authenticate. Then I select the databases that I want to migrate. So in this case, I'm just going to select all of them. Then I select optionally the logins that I want to kind of migrate. Now, it's not going to be able to migrate any Windows logins because Windows logins as such aren't supported on managed instances, although they do have Active Directory integrated logins that are kind of similar, but not quite the same. But it will kind of migrate SQL logins. So here I've got a login used called App1 and a login called ERP. So it will migrate those for me. And then I've got a bunch of configuration settings, such as where are the backups. If it's an offline, then it's going to have to go to there. If it's online, you can get it to create the backup files for you. What user account do you want to connect to the share? And then a SaaS kind of URL with the SaaS token about where it's going to put the backups. So what it's going to do, it's going to take the backup and then use AZ copy to effectively put the backup into the blob store and then restore from there. So I'm going to click save. Here we go. It's now going to confirm what it's going to do. So it's going to migrate 6 databases, and I click on Run Migration. Oh, got to give it an activity name. Bob Activity. I'm now going to run my migration. Okay, so that's now going to asynchronously run in the background. I can refresh it to check the progress. Okay, so it's just started. And if I really wanted to see what was going on, I guess I could connect to the relevant SQL servers, either the source or the destination, and run like SB who is active and see what's going on. So let's just leave that running. And now a while later, I can see that's actually finished. Okay, so number of databases migrated 6, number of logins migrated 2. If they had failed, it would give me the number of failed, and I could double click there and either download the report or get the error message. Now let's go over to the jump box here, and I can see here's my source databases that I migrated using the wizard. And if I go into security, here's you can see I've got these logins that I wanted to migrate, and I'm going to connect now to my managed instance. Oh, no, wrong one. Managed instance, go. Now, I can see now on my managed instance, I've got all of the databases, and I've got the logins as well. Nice. If I right click on any one of the databases, I can see there'll obviously be some differences because it's a managed instance. I'm not going to have like a C drive or a data drive. Instead, the data in the log file are going to be stored on the blob store. As I said, it's going to be stored on a remote blob store on an SSD. Okay, so I can now quite happily query those databases on the managed instance. Now, that's not our favorite way of doing migrations. Okay, the reason is it's migrated to user databases and the logins, but a migration could be there's a few more components that we probably want to worry about. If I go into the system database, I can see, for example, we've got stored procedures in the master. If I go into the agent, I can see I've got jobs I want to locate. There's a ton of other things that that a senior SQL professional will be aware of. Custom errors, master keys, linked servers. So there's all these components that are installed that are outside of the user database and you might want to migrate. So I'm going to show you our favorite way of migration, which is the DBA tools library. As I said before, the most popular tool in the SQL community for doing SQL migrations from any flavor of SQL Server to any other flavor is the DBA tools library. So I've put a link at the bottom of the deck where you can see some more sort of videos and download it and stuff like that. I'll jump straight into a demo. Okay, so if I pop back onto my jump server, I've got the web page for the DBA tools here just to really show you the sheer number of commands that it supports. If I go into backup and restore, I can fully automate backup, restores, testing, and so forth. There's also a section here on migration, which is what I'm interested in, where we can automate the migration of any type of component from one kind of SQL Server to another SQL Server. So that's worth further reading maybe, but I just want to show you an end-to-end demo of it in action. So I install the various kind of modules in PowerShell here, and then I'm going to use one of the DBA tools libraries backup database. If your source is SQL 2012 CU2 onwards, then it natively supports backups direct to the blob store. So you may already have all your backups. So just an example, I'm going to run this, and what this is going to do is back up just a single database to the blob store. So I run this, probably do it fairly quickly, bang. So I've now got one of my user database is sitting in the blob store. Just to show you that, I've got Azure Storage Explorer here. I can see on the blob store, I've got my backup appear. Yay. Now, if it's before SQL 2012 cumulative 2, there's no native backup to the blob store. There's no real kind of loss. All you're really going to do is back up, but this time to a backup directory, which is the approach that the data migration services take, right? So I've got a local backup directory. Now on a hopefully a server would have some sort of disk space or a network share, right? So, and this time I'm going to back up all of the databases on this 2008 R2 instance. Let's fire that away. Hopefully it won't take that long. Bang. Right, so I've now got on my hard drive, hopefully, if I go to my backup folder, oh, I've got one I did earlier. Right, let's just get one backup. I've got that sitting in that folder there. Okay. Now, once I've done that, there's a little bit more PowerShell script to then use this command, set as a blob content, to effectively upload the sort of backup. I could use a tool like AZ copy or something like that, but I'm going to use the PowerShell kind of library, right? So when I run this, it's going to take that blob store, take that 2008 R2, upload it to the blob store. I click refresh. I've now got one new sort of database and one old one from 2008 R2 sitting in the blob store. Now I want to restore all those from the from those. So using a bit of PowerShell now, I can use this command, let get Azure get AS storage blob to get all of the blobs that are in that container. Okay, so I've got a variable for the container, and then loop through each of them, create the full name that is the full kind of URL of the backup, and then there's another DBA tool command called restore DBA database, and when I run that, it's going to restore it to the managed instance. Okay, so let's run this. Now this is going to take a few minutes because as part of the restore, it's got to create the disks, and don't forget that's into a provisioning process because per user database it's got to create an SSD on the remote blob, attach it to the SQL Server, and then do the restore. But let's get this running. All right, so that's started. And let's see how. Oh, my bad. I've actually got an error message here. So if we look at the error message, the specified network password is not correct. So what that means is the managed instance has not been able to authenticate to the blob store. The reason is there's a SSAS token that has to be installed on the managed instance. So I'm going to go to SQL Management Studio. I'm connected to the managed instance, and if I do select star from sys.credentials, I can see there's no credentials stored. So this is the T-SQL to store a shared access kind of signature on a URL. So I'm going to restore that, and then I'm going to come back to here, and now I'll be in a position to hopefully redo the restore of the databases here. I've just pushed F5, and now we've got to wait for the databases to restore. Oh, hold on. I've just got a missing library, so I'm just going to install that, and then I'll proceed on. Okay, so now that that's finished, I'll get a PowerShell output with a list of the user databases that have been restored and where they've been restored to. Now ignore this path here, because it's a managed instance, that's actually just a mount point. The actual database is going to be stored in the remote blob store. Now, so with a few lines of PowerShell, we can actually do the backup and the restore fairly easily, even if it's an older copy of SQL Server. The other thing is it's even easier because there's actually a function called copy database, which will do the backup, the restore, and everything for you. You've just got to supply a shared path for where you want to store the backup. So just to show you this, I'm going to take two of the user databases that haven't been restored yet, the sales and the stockDB, and I'm just going to use this function here. Okay, so this is kind of nice and easy. I give it the parameters of the source and the destination. Let's run that one. Now it'll take a little while to run. Okay, so now that's finished, I can see that these two databases have been restored successfully. If I go over to Management Studio in the Managed Instance and refresh the user databases, I can now see I've got these extra two databases. So using the DBA tools, the syntax to kind of back up and restore and migrate between SQL servers is, I don't know, I find it much easier than the data migration services wizard there. Now, that's all fine and well for user database, but let's look at full server migrations now. So I've got another PowerShell script, which is using another commandlet in the DBA tool, start DBA migration. And this takes similar parameters where we've got a source, which is an on-premise SQL server, a destination that is a managed services, and a shared path for storing any backups. But now there's a ton of extra parameters where I can exclude or include other components that complete the migration. Credentials, logins, agent server, which is basically job stuff, the user databases themselves, SB configure options in the SQL, any database mail settings such as operators, alerts, SMTP operators, any objects that are in the master database or MSDB. For example, if I go to my source server and into my master, I can see that there's some stored procedures have been added, such as SP who is active, and other ones that I might want to migrate. Linked servers, and extended events and triggers. Now, you might not want to migrate all of these over, but this gives you the options. Okay, so I'm gonna take away this agent server. Oh. So now it's going to also migrate my jobs as well. So it's just going to migrate jobs. I'm going to click run, and now it's going to migrate the jobs between all the servers. So you see here, it skipped a load of ones, a load of the schedules that were already on the server, and it's added some agent jobs. And if I go to the jobs on the Server now, I can now see I've got the 3 jobs have been migrated. Now, I could, if I wanted to, migrate some of the other objects. For example, if I take off the sysdb user objects and run it again, it's now going to also migrate jobs and any objects that it finds in the system databases that are user objects. So let's leave that running. Hopefully it won't take it too long. And bang. So it's now found, now some things, most of this that was already on there, but if it wasn't on there, it would have migrated that for me. So we can see that using DBA tools, we get a fuller migration, including a lot more objects that you'd get than if you were using the data migration services. Now, the last thing that we're going to look at is the other components. So analysis services, integration services, and reporting services that are commonly installed on SQL Server. Now, as we found out, the actual database engine is no problem. That can go straight up to manage engine. But for the other components, for SSIS, you can deploy platform as a service. So Azure kind of Data Factory version 2 has a fully hosted model for SSIS. So there is a platform as a service, or you can choose to have a virtual machine that just has those components running. And the same is true for most of the other offerings. Analysis services, if it's a tabular engine, there is a platform as a service offering. If it's MoLap, it's pretty much got to running a virtual machine. Or reporting services, Power BI Premium has a platform as a service offering, so you can migrate your RDL files up to that, or you can continue to run in a VM. The choice is yours. Okay, so that's about all the time that we have. Thank you very much.